What it means in English.
Okay, number one, what shape do you think it is? In your box, real mineral, what is its shape? Good, write it down.
Hexagonal. Yeah, we are.
How many sides is it? How many faces?
Next, on your cheat sheets, we are letter D, the streak test. Open your little zipper bag, little plastic zipper bag, and you will find a unglazed porcelain tile. Unglazed, white unglazed porcelain tile. Set it down on your tabletop. That's number one. Whoa. Yes. Your number one should look like this.
Now it makes sense.
Still glassy. Okay. Here we go. It says, rub your sample across the streak plate. Set the streak plate down on your tabletop. Take sample number one and rub it across there, and you describe, once is enough, you describe color and texture of what's left. Do you see any residue on your streak plate? That means that your mineral is harder than that streak plate. None of it powdered or rubbed off. It left no streak. So write, no streak or none. If it leaves a streak, you're going to describe color and texture. Textural terms are things like chalky, greasy, gritty, some other word to describe. There is a mineral famous for its streak test. It's a gray mineral. You streak it across the streak plate, and it's called a blood red streak. Red is the color descriptor, blood is the textural descriptor, okay? And so, very subjective for the descriptions of the streak, but to say that it has a streak does in fact tell you a lot about the mineral. You'll see that when you key it, okay? All right, next test on your cheat sheet. You will go to a station in 222. We are not going to give you hammers and have you break up all of your samples. This test would best be called the breakage test. We have taken one sample, hit it with a rock hammer, and put the pieces in petri dishes. So you have rock microscopes. You're going to take the petri dish, take off the lid, put it under a microscope, use the hand lens, and you are going to record either cleavage or fracture. Cleavage means it looks like a nice, smooth cut by a knife. A cleaver, a cheese cleaver is a big old knife. And so if you see broken edges that are nice and smooth, not all minerals will cleave in all three dimensions, some do. But if you see any cleaved surfaces, you write cleavage. We're not going into it deep enough to say how many cleaved surfaces and what angles they cleave at. That's a graduate course. Okay. F, hardness test. Inside your little plastic baggie, you have the field items for Mohs hardness scale. It is page number 18. It's on the back side of your crystal shapes. So arrange these things in sequence on your table. Your fingernail, these are Mohs minerals right here. I find with children to have a set of unknowns and a set of Mohs minerals, minus a diamond of course, is too confusing. I spend all of my time getting Mohs minerals separated from their unknowns. So I don't use Mohs minerals. I just use the field hardness things, the things that you would use if you're out hunting and find something and you want to test it. So we're gonna use our fingernails, and our fingernail has been rated by Mohs scale to be a 2.5. That means your fingernail is harder than talc, it is harder than gypsum, but it is not as hard as Mohs number 3 calcite. Your fingernail would scratch talc and it would scratch gypsum, but can it scratch calcite? No. And so, next is a penny. A penny has a hardness of 3.0, rated against Mr. Mohs' hardness scale. Then you have a nail, which is a 5. And then you have a piece of glass, which is a 5.5. And then you have a little bitty steel file. The first test, if you use your fingernail, you do not put your fingernail down and scratch it with a mineral. Do not let children do that. You just take the sample and see if you can scratch the sample with your fingernail. You can damage their nail, the cuticle of their nail, by doing that. So you scratch it. If it powders off, you know that your fingernail is harder than that mineral. From here on, you lay these items down on the table. Do not let children put this or this or this, even the penny, in the palm of their hand to do a hardness test. You put those items down on the table. That's for safety reasons. So, do you have your items arranged? All right, let's begin. Take your sample number 1. Check it with your fingernail. Can you scratch it? Everybody try it. We know it's harder than a 2.5 because you're testing it with your fingernail. Next, go to the penny. Lay the penny down. Take your sample number 1 and see if you can cut it. When you run it across it, take your fingernail and wipe it. You want to see if your mineral is powdering off on it or if you're really etching or cutting the penny. What did it do? It scratched it. We now know it's harder than a penny. Next, go to the nail. Lay the nail down sideways on the table. You're going to scratch your mineral along the shaft of that nail, the long axis of that nail. Check it. Tell me yes or no. Did it cut it? It did. We now know it's harder than a 5. Set the piece of glass down on the table. Do not hold it. It could break in the palm of your hand. Your pieces are polished on the edges. I've had to do this the poor way and just have blows cut me some pieces of glass, and so those were really dangerous. We sanded them, but they were still dangerous if you're holding it in the palm of your hand. So did it cut it? It's harder than how much? 5.5. Take your steel file. I want you on one of the polished surfaces, not on the part of the steel file that has been edged to file with, okay? Not on that part, but on a nice smooth part of your steel file. Lay the steel file down and take your number 1 and see if you can scratch that steel. The textbook says to use a pocket knife. A pocket knife would be something that you would likely have on a field trip, right? But you don't give kids the pocket knife blade. Question.
Which part of the,
Did you say textured or untextured part?
Untextured part of the steel file. Yes or no, did it cut it? So what do we know about number 1? Right, greater than 6.5. Otherwise, you would be writing a range. You don't know anything about between a penny and a nail. So if it is harder than a penny, but will not scratch the nail, you would write 3-5.0. It's somewhere in that range, and that's all you know. You don't know anything specific about it other than it's between here and here, all right? So if you can scratch it with your, if you can scratch it with your fingernail, you would know that it was soft or less than 1 or less, okay? All right, questions about hardness? Hardness will take you a little time.
So at this time, as math teachers, could you introduce the compound inequality and have them write it as a compound inequality, where the substance is going to be greater than
Or less than.
3.0 but less than 5 point,
If they know inequalities, you certainly can.
yeah.
Okay.
I have a question about the nail.
Okay.
I've seen plastic nails lately at Walmart. So it's an iron.
It needs to be a galvanized nail. Galvanized nail. They're in your kit. They come in these little kits. All right, but if you go to make kits for children, then you would need to buy galvanized nails. And I use the great big galvanized, where they're not quite so sharp and more surface to, yes.
Okay, one more time with the fingernail, because every time I've done a test with this, I've always had the kids scratch it like that. But you said don't do this to scratch your.
No,
Okay.
to do that.
Always have them.
You were doing it the right way the first time.
You were,
Okay.
yes. That's the only one that you do the reverse.
With everything else, you try to scratch the substance.
The substance that you know the hardness of,
Okay.
but you do not do that with your fingernail,
Okay.
okay? Perfect. All right, next test, we are on specific gravity. Now, your procedure, since you have had density training already, most of you, yes, we are changing that procedure. So what you are going to do is you are going to take each sample and you have a separate worksheet. It is page 19 in your binder. It looks like this. And by the way, do you see those X's on number 2? Do not do specific gravity on number 2. Look at number 2. What are your suspicions about it? It's going to dissolve. You will not have a crystal. So I've given you the specific gravity for number 2. Help one another remember, do not do specific gravity on number 2. Okay, so what are you going to do? You're going to use a triple beam balance and you're going to mask the samples. Record right here on that data table. You are going to find volume by displacement. You are going to use a cup. Can I borrow yours? I don't have an extra here. You are going to use an overflow cup like this. You're going to keep this sitting in your tray and preferably pull your red tray over to the edge of your table so that this spout would be sticking out. And you are going to You have water in containers. Since we only have one sink, we didn't want you wasting time standing in line back there. So you will add water to the cup, and if any spills out, it's going to spill on your red tray, and I'll be passing out paper towels. And once it has dripped over just a little bit, you will gently put your sample in here. Don't just plop it in and splash water. And you're going to be catching the overflow, the displaced water, to get its volume. And these are very, very accurate. Be sure you determine the precision level. Everybody doesn't have a graduated cylinder of the same precision, so be sure and check this before you read, okay? And you're going to record volume here. And then density is a ratio of mass to volume. Did I say that right? It is a ratio of mass to volume, and you are going to divide. Divide the mass by the volume. And then you are going to divide by the density of water. And so you have on your tabletop one of these for each of you. This is a liter box. The metric system is so amazing. It's easy to change units. You don't have to memorize a bunch of stuff like you do in the English system. But the real beauty of the metric system is it's all based on a standard called water. So this box holds 1 liter of water. And inside here, there are 1,000 little bitty centimeter cubes. Right, now I'm gonna spill them all on the floor. I should have had one out. Here is a centimeter cube. That centimeter of water would have a mass of 1 gram and would occupy how much volume? How much space would it take up? A cubic centimeter, but tell me in the graduated cylinder how much that is. 1 milliliter. Okay? So this is a liter of water. It is a kilogram of mass when it's filled with water, and it is 1,000 cubic centimeters. All right? And I think you're gonna do something with this now, later, when? Later, okay?
So the metric system is based on water?
Yes,
That's where it all comes from.
that's right. Isn't that cool? All right, these are pretty neat, I think, for math too.
We use them all the time.
Use them all the time, see? Okay, so I want to ask you, if you're dividing,
Hold on.
if you are dividing the mass of your sample by the volume of your sample, what units would density of that sample be in? Grams per milliliter, because you're using displacement. And water's density is 1 gram per milliliter. So you're going to divide the density of your sample by the density of water. So what will the units for specific gravity be?
Can you put that on the elbow so they can visualize it?
Here's your paper. Put them on there. Here's your pen. All right, everybody watch.
So density is what?
Grams per milliliter.
Grams per, I heard mass first, I'm sorry. Grams per milliliter, and you're gonna get that one, and then you're gonna divide by what?
Gram per milliliter.
So you flip it, cancel each out.
What do you, the,
Density of water is 1 gram per milliliter.
so gram per milliliter again? So what are your units?
If you flip them, they cancel out, they eliminate.
So you have no.
There is no unit.
No unit?
No unit.
How did you get no unit?
Because it's a fraction over a fraction. When you flip by the reciprocal to multiply it by the top, they cancel each other out.
When you flip what?
The secondary fraction.
So you take the reciprocal of the second one?
And then by possible elimination, they,
You just take the reciprocal, that's all you do?
no, it's from the bottom, and then when you bring it to the top, you flip it to make the reciprocal, and then when you multiply, you can cancel out the like terms from.
Oh wait, multiply?
Mm-hmm.
Explain that.
Welcome to Dr. Browning's class. You notice that veteran is not speaking right now.
Dividing fraction.
Dividing fraction.
Yes.
So we took the reciprocal of the second one, the
Correct.
higher, and then
Now
this
you,
becomes
it's multiplication.
multiplication. Okay, you needed to say that. So what's gonna happen here, I'm gonna write it another way.
Can I ask about that? Is it because you're taking the reciprocal that you do the opposite?
That is like, that's a
Process.
long lesson, and
Okay.
I will go into that, but not right
I
this
just taught
minute.
that last night.
So if we have grams
It's grams
times
per
milliliters, which is what that is. Right, so you multiply, it's top times top, bottom times bottom,
milliliter.
and over
Grams.
milliliters times grams. I heard a lot of blah, 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 we have no units, why?
because they turn into,
Because
it turns into one.
Right, it's
You
simple.
simplify, you simplify.
Okay, you
Like
simplify because these will, I heard the word cancel, it's not, we can use that
Eliminate.
word now, but it's not the proper word. So these
Anything
cancel,
divided by itself is one.
Is what?
these cancel, so what are the units left?
Whatever.
One.
One.
Understood is one, which is that.
There are no units left.
Does it become one? We don't have any numbers there. We have no numbers, so how can it become one?
Because one is understood to be there.
One is understood, the
If you
1
have it-
gram, 1 milliliter, 1 gram, 1 milliliter.
If you have the symbol, then you have to have at least one, right?
Okay,
You have to have one.
okay, y'all buying this?
Well, because how do you do a mathematical application with now?
Kim,
I'm asking a question.
okay, wait till they finish though, because they may say it, okay? So, I lost my train of thought, where was I?
One.
Why?
Because it can't be none,
Can't be none.
and there is no,
Because.
it's just 'cause it is.
That's what we're trying to overcome.
Right, because, yeah.
Because one is understood to be there, but it's not necessarily a numerical value, it's just a
Hang on.
placeholder?
So we can assume there's a 1 in front of all of these?
Correct.
We can?
Since
Does
you're
there
not,
have to be?
Yes. Actually, there does.
There has to be.
it can't be
If
zero.
you have, if you have a symbol, you have a
We're talking just about units.
It has to be a unit.
It has to be a unit, all right. So all of these have 1s in front of them?
Correct.
So we're left with the 1 times a 1, which is a 1. 1 times a 1, which is a 1, which is? 1 what?
One space.
One specific gravity.
Ooh, yes.
What did you say, Jen?
Patty, 1 what?
They're naked numbers, they're no units.
It is no longer labeled.
Almost like a scale.
They're naked numbers, which means they don't have units. We don't like naked numbers in mathematics.
No, we don't.
And y'all don't like them in
We
science
don't like
either.
science either.
But this is a naked number, no units, so what do you call it? It has a specific gravity of a number, right?
It's a specific gravity of your mineral compared to an equal volume of water. So if its specific gravity is 2.1, that means that that mineral is 2.1 times more dense than that much water would be.
And there's no unit for that.
That's right.
Right.
So it's a sentence. Okay, it's a verbal description. It's a sentence. Would you say that sentence again? If the specific gravity
If the
is,
specific gravity is 2.1, that's what your sample number 2 was, right?
Right.
That means it is 2.1 times more dense than that same amount